Hello, and thank you for joining today's presentation on how to solve common mold release problems. My name is Angel Perez, and I'm joined today with our presenters Joseph Nordstrom and Daryl Taylor. Before we start, just a few housekeeping items. While how to solve common mold release problems are speaking, if you have any questions, please submit those to the Q&A box, and the team will answer those at the end. In case you experience any technical issues, we are recording today's webinar and we'll be sending a link so you can watch on demand. Finally, we have a short survey following today's presentation for you to provide feedback. I'll start with the agenda. Today we will see some best practices on how to easily remove molded rubber parts. Then we are going to talk about the different mold releases types in the market, followed by all our lock release solutions. And finally, an introduction of our newest launch, Lock Release 237. Before start, I would want to introduce our presenters. Daryl Taylor is an application engineer with the Parker Lord Application Engineering team based in Erie, Pennsylvania. He is in his 28th year of service with Parker Lord. Daryl has experience in molding, process, and application design. He currently provides audits, customer training, new product introduction, and troubleshooting of Chemlock, Lock Release, and IMB. He obtained his BS in Industrial and Engineering Administration from Edinboro University. Daryl resides in Cambridge Springs, Pennsylvania, with his wife and two children. Joseph Nordstrom, he currently is Technical Support Engineer for Parker Lord with 6 years of experience in the department, 9 years of experience as the Health, Safety, and Environmental Manager split between 3 facilities. Facility Manager of a post-industrial plastics recycling facility outside of Parker Lord for 3 years, and multiple positions in the product quality department at Chemical Division across 5 years, including Product Quality Lab Manager. Today, Joseph and Darrell will be sharing their expertise and knowledge about mold releases. Both are two of our best application engineers in Parker Lord. With that being said, Darrell, I turn it over to you.
Thank you, Angel. This is Daryl Taylor. I will be discussing the first topic today is how to easily remove molded parts, and we will focus on the process and best practices. There are a lot of prep work to be completed before getting to the mold release step in molding. Every step in the process is equally important to producing a robust product. For instance, when you receive your metal inserts from your supplier, you must verify that they meet your requirements. Otherwise, they may not meet your customer's requirements and simply may not fit your mold, causing delays in shipments. Likewise, when you apply mold release to the mold, the best practice is to apply light coats in multiple directions, allowing the solvent or aqueous carrier to flash off between coats. Make sure the entire surface of every cavity is equally covered by changing the angle you spray at for each light coat so the shadowing effect is minimized. If the mold release product is applied too heavy or too light, you will end up with parts that don't meet your requirements and ultimately don't meet your customer's requirements, as well as potential downtime to clean a dirty mold. Common problems related to mold release and improper application procedures or techniques are mold fouling, overspray, underspray, transfer to the part, and flash rust of the mold. We'll start with mold fouling. Mold fouling is when the rubber adheres to the mold surface, causing tears in the part and potentially affecting the quality of the part. The reasons for mold fouling are over or under application of mold release, too long between applications, or compatibility of mold release for the adhesive and rubber combination are not correct. If mold fouling is detected, it is very important to clean the mold and reapply the mold release. Overspray is when the mold release is applied too heavy. When the mold release is applied too heavy, there will generally be a residue on the mold surface, which is the release agent that was not able to cure or adhere to the mold surface. If overspray is detected, you can use a clean dry rag to wipe off the excess prior to starting the molding cycles. Generally, that will clean the mold up well enough to be able to mold parts without having mold fouling or transfer to the part. The reasons for overspray are utilizing the wrong equipment and possibly operator training. You will see later in a training video how the equipment and application process used can make a difference in application of the mold release product. Next is underspray. Underspray is exactly what it sounds like when not enough mold release is applied to the mold. Underspray is hard to detect before molding cycles start. If the underspray is suspected, you will notice after your first molding cycle that the parts are harder than normal to eject from the mold, and there may be some mold fouling or rubber tearing that will be left in the mold. Underspray can also be caused from the shadowing effect. The shadowing can occur in any mold, but will be more evident with molds with deep cavities or cavities with a lot of different geometry within them. So it's important to apply your mold release evenly on the mold. Get several coats at different angles to make sure that all the shadows are covered. And next is the transfer. When you have transfer to the part, it's generally due to over application of mold release or not allowing enough time at the appropriate temperature for the mold release to cure. Transfer to the part can cause issues if post bonding operations are required, such as painting or post vulcanization bonding. Special cleaning operations are required if any mold release transfers to the part when you have these secondary post bond operations as part of your process. Those secondary cleaning operations can be quite lengthy and cause a lot of downtime. So it's best to make sure you apply the mold release at the right level so that it doesn't transfer to your parts. Other problems from transfer to the part are potential bond failure in knit lines in the elastomer. These problems can become a concern when mold release is excessive enough to transfer to the part. Cleaning the mold will be necessary and reapplication of the proper amount of mold release and allow enough time to cure at the appropriate temperature. Next is flash rusting. This is not generally a concern, but if it can occur, when you're using aqueous-based mold releases, it is important to not flood the mold with the mold release and apply a fine mist that flashes off almost immediately. Usually the flash rust can be wiped off with a clean dry rag if detected early enough before it becomes a problem. Next, we will discuss the types of mold releases, chemistries, and some performance. There are 3 categories every mold release can be placed in: sacrificial, semi-permanent, and permanent. The sacrificial mold releases are generally inexpensive, can easily transfer to the part, and require frequent applications. Semi-permanent are moderate cost, formulated to adhere to the mold to limit transfer to the part, require a clean mold for the best performance, and are less likely to cause bond problems. Permanent mold releases are generally higher cost for the product, as well as the application process equipment required for the high temperature bake cycles. However, the permanent mold releases provide for many cycles before touch up is necessary. The types of mold releases that are most common are the PDMS, PTFE, and waxes and soaps. There are other types listed on the slide which are less common and have more specific uses. Characteristics that you want from a mold release are they have low surface energy, good wetting, good adhesion, heat, and chemical resistance. The trade-offs for these characteristics will need to be understood by looking at the compatibility, cost, and performance of each product. It is important to note that all lock release products are modified PDMS or PTFE and considered to be semi-permanent. And now I will hand this over to JR, who's going to discuss lock release technologies.
Thank you, Daryl. In the next few slides, we'll be reviewing Parker Lord's lock release technologies, covering the 100, 200, and 300 series products. These products supply value, providing fast curing, non-transferable coatings with anti-stick and reduced mold fouling characteristics. 100 series mold releases are solvent-based. They're non-transferable to the rubber and do not contain any Class 1 or Class 2 ozone depleting substances. 111 trichloroethane or methylene chloride solvents are absent from the formulation to ensure the product is environmentally preferred. The 200 series products are water-based mold releases, making them environmentally preferred as well. They adhere well to the mold, providing a strong, non-transferable release agent. Our 300 series is also a water-based mold release, providing a silicone-free product option. Like the other series, these are non-transferable to the rubber surface and environmentally preferred. Lock Release 100 EZ provides the 100 series product in a convenient aerosol can for easy application to smaller molds or for mold touch-up. It is designed for use with EPDM, natural, nitrile, and neoprene rubbers. It's a semi-permanent mold release, providing an anti-stick coating, allowing for fast, easy part removal. Lock Release 100 provides the same performance as Lock Release 100 EZ, but packaged in larger container sizes. Lock Release 100 series is recommended for non-bonded manufacture and injection, compression, or transfer molding operation. Bonded components using this series are typically done in compression mold processes, but some exceptions do occur. Lock Release 200 and 210 provide a non-transferable anti-stick coating designed for EPDM, natural, nitrile, and neoprene rubbers. These water-based mold releases are designed for use in the manufacture of molded parts, as well as rubber bonding operations in injection, compression, and transfer molding. Lock Release 237, our newest mold release offering, is a PDMS-based release for use with natural, SBR, nitrile, and other rubbers. This semi-permanent, water-based release is designed for use in part molding and bonding operations in injection, compression, and transfer molding. Additional details on this product will be covered shortly. Lock Release 300 provides a silicone-free mold release option designed for use with fluoropolymers, plastics, epoxies, plastic laminates, and molded rubbers. In the following slides, we will review some advantages of Lock Release 237 as well as proper application techniques. As previously mentioned, Lock Release 237 is a fast-curing PDMS-based mold release designed for use with ChemLock products in compression, injection, or transfer mold operations. It's a semi-permanent, non-transferable coating that reduces mold fouling and allows for easy part removal. This mold release was designed specifically using Parker Lord ChemLock products during its lab development. Lock Release 237 is a robust mold release working with multiple compounds such as EPDM, natural, nitrile, and neoprene rubbers, as well as working with epoxy or plastic laminates, silicone, and fluoropolymers across the majority of all molding process types. The mold release is designed to supply our customers advantages and cost savings within their processes. Lock Release 237 is available in multiple dilutions delivered straight from Parker Lord. It is designed as a low build coating that resists mold fouling, increasing customer production volumes between necessary mold cleaning cycles. Lock Release 237 is designed to be a durable mold release that is easy to apply, has short cure times, and delivers multiple mold cycles from a single application. This product's robust nature results in decreased defects due to rubber stick. This tailor-made mold release is available in multiple container sizes, from gallons up to tote quantities. Variable off-the-shelf dilutions are available, ranging from the pure concentrate to 1 to 3 dilutions. These were designed to meet our customers' varying mold requirements. Now we will review the application procedures and touch on the general properties of the product. The mold surface must be clean and free of contaminants prior to the application of Lock Release 237 for the first time. We recommend plastic media or dry ice blasting of the mold to remove fouling or old mold release from the surfaces. Any custom dilution of Lock Release 237 should be done with deionized water. Spray application should be performed using a fine mist across the mold. 3 light coats of the product to a preheated mold between 100 degrees Celsius and 200 degrees Celsius is needed to ensure the initial coat provides robust performance. The product technical data sheet should be referenced to determine the proper cure time for Lock Release 237 depending upon the mold's temperature. Please make note, touch-up applications done after the initial mold treatment will only require a short 1 to 2 minute cure time when the mold temperature is above 100 degrees Celsius. The following video will present proper application technique for initial coating and touch-up processes of Lock Release 237. Also included are examples of improper application technique and how to identify over-application to the mold surface. And now I'll hand this back to Daryl, who's going to discuss some information on trials and performance.
Thank you, JR. Now that we have discussed the best practices of application of mold releases, let's look at some of the Lock Release 237 performance compared to a control and competitive products. Each product in this case study was applied at what we would consider as a heavy application. ASTM D429B coupons were injection molded after heavy application, and the samples were tested to destruction, and the PSI strength of the elastomer was used to rank the samples and the amount of mold release that had swept from the mold and into the rubber. The control and Lock Release 237 are pretty much equivalent whereas the two competitive products have, around 50% less PSI strength in the rubber due to the transfer of mold release into the rubber. The photo on the bottom right is of the rubber section from the competitive product and indicates a high level of nit lines caused by the amount of mold release that is in the rubber. Proper application of Lock Release 237 will not cause nit lines or other defects in the elastomer. Parker Lord has a rubber to metal molding facility in Bowling Green, Kentucky that trialed Lock Release 237 before the product was launched. 3 different adhesive processes, along with natural and synthetic rubber, were used in these trials. The molding parameters are listed in the table and are standard for the industry. More mold cycles were performed with the Lock Release 237 and the control mold release, and parts were hand stripped from every cycle to determine the level of bond after using Lock Release 237. And there were absolutely no bond issues found during the trials. The quotes on the right-hand side of the screen there are from the engineering folks and production operators, essentially stating exactly what happened during this trial, and they're all positive for the Lock Release 237. And now I will hand this over to Angel.
Thank you, Joseph Nordstrom and Daryl Taylor, for that great presentation. We have received a lot of great questions from the audience. Before we get into the Q&A, just a reminder that if you have any questions, please submit those to the Q&A box. Before moving to the Q&A section, I will want to share that if you need additional information, you can ask to your regional account manager about this troubleshooting guide. Every examples and cases shared during these webinars from our experience and experience from Daryl and JR. But we know that there are many situations that we didn't cover. With this troubleshooting guide, we try to cover as much as we can, but if you still have different situations, you can always contact our technical team. Where to find more information? About the recently launched that JR told us, Lord Lock Release 237, I will tell you where to find more information. The main resource to use is to ask to our account manager or anyone on the team, David Sheffield, Elizabeth Wilson, Daryl Taylor, Joseph Nordstrom, Rosa Manini, or me, Angel Perez. This is our most recently launched, and we will want to try with you this new technology.
That wraps up our presentation. We will now open up questions from the audience.